Hello guys, you're watching the Supermileage show. This is Datrisham. Let's get started. In the previous episode, we discussed the mechanical overview of our car. Today, we'll be talking about the electrical systems that actually make our vehicle an electric vehicle. Before we do that, here's some interesting EV news of this week. The Delhi government has announced the new electric vehicle policy. So what does it do? Say suppose if you were to buy an e-rickshaw or an e-bike, you'd get incentives of up to 30,000 rupees. Also for that matter, if you chose a 4-wheeler battery electric vehicle, you'd get incentives of close to 1.5 lakh rupees. That's not it. The Delhi government aims to have more than 25% of its vehicle population to be completely electric by the year 2024. That is just 4 years from now. Is that an achievable number? Only time will tell, because the current numbers are clearly not suggesting the same. The current EV population in the Delhi market is just lesser than 0.29%. Yes, just 0.29%. Moving on, the Global Action Plan, which is the charity behind Clean Air Day, is urging for the UK government to set a new EV sale quota. So if implemented, what does this do? Just say, for suppose, you're an XYZ automobile manufacturer that is located in the UK and you set out to get at least 100 new products in the market. Then, according to this scheme, you would have to have 15 products that are completely electric vehicle based. I mean, this 15 sounds very small percentage, but seeing the current population of electric vehicles in the UK market that stands at around 3%, this surely gives us a hope for having at least close to 20% of electric vehicles in the UK market by at least 2025. Like mentioned earlier, in this episode we'll be dealing with the electrical overview of our vehicle. So we could be discussing about the motor, a battery, the battery management system and the motor controller, just to name a few subcomponents that make up the electrical overview of our vehicle. Today I have with me Abhijit, who is also the electrical lead at Team Inferno, to discuss these concepts. Hi Abhijit, it's good to have you on show.
Hello Datrish, thanks for having me. I'm so glad to be here.
So Abhijit, could you brief us about why we are using the type of motor that we use and what are the alternatives that we have to the same?
Absolutely Datrish. Well, I'd like to start by talking about essentially the two main types of DC motors, the brushed DC motor and the brushless DC motor. Now, we at Team Inferno uses BLDC motors, brushless DC motors. Now, before I explain the working of a BLDC, I think it's better we understand the working of a brushed DC. In brushed motors, there are permanent magnets on the outside and a spinning armature that contains an electromagnet in the inside. These electromagnets create a magnetic field in the armature when the power is switched on and helps in the rotation of the armature. So basically, in a brushed DC motor, the permanent magnets are attached to the stator, which as the name says is static or doesn't move, and rotor, which is a rotating part, has the rotor windings. Whereas in a BLDC motor, the permanent magnets are attached to the rotor and the coils are on the stator. Now, in a brushed motor, when the rotor spins, we need a method of energizing and de-energizing the coils on the rotor while it's running. This is accomplished by the brushes in the brushed DC motor. The brushes can also change the polarity or the direction of rotation. Now, this is very important. The voltage level controls the RPM of the motor in a brushed DC motor. But in a BLDC motor, like the name says, there are no brushes. Well, then how is it energized and de-energized, you ask? Say hi to the motor controller. Now, bear with me here. I'm going to get a little technical. Now, we've all seen two wires coming out of a brushed motor, right? The red and the black wires. Like I said, in a brushed motor, the RPM is essentially controlled by the voltage supplied to it. But in a BLDC motor, there are not two but three wires coming out of the motor. And each wire is responsible for 1/3 of the rotation. That is, if 360 degrees is a complete rotation, then each wire is responsible for 120 degrees of rotation. So the three wires are energized in a certain sequence, one after the other. The three phase wires R, Y, B are pulled high and low in a certain frequency. At any instant in a BLDC motor, one wire is pulled high or energized, one is pulled low or grounded, and one is left open. So for example, If R is high, then Y is low and B will be open. 120 degree of motion is achieved, and then the next sequence is initiated where Y is high, B is low and R is open. And then the next sequence, the next. So 1 2 3, 2 3 1, 3 2 1, or RYB, YBR, BRY. Now this keeps continuing, and the RPM is controlled by the magnitude and frequency of the current, not the voltage, but the current that is applied to the each phase wire. Now in brushed motor, the RPM was controlled by the voltage, but in a BLDC, the RPM is controlled by the frequency and magnitude of the current. Now that's basically how a BLDC motor works.
Moving on to the batteries. So what is a battery? A battery consists of electrochemical cells that basically convert chemical energy to electrical energy. This is the most basic definition of what a battery is. So what are the types of batteries available? There are the primary batteries and the secondary batteries. So when you look at a primary battery, it just has a one-time application and it can be used only once. So it cannot be reused. And to give some examples, we have the dry cells and the alkaline batteries. When we turn to the secondary batteries, these are rechargeable batteries. And nickel cadmium, nickel metal hydride, then lithium ion technology and lead acid technology all fall under the secondary batteries category. We'll be discussing in brief about the secondary battery technology. The lead acid technology. It's probably the earliest type of secondary battery technology available to mankind. Even though it's so old, in today's world we find very little applications of the same. Why is it? It's because of the poor performance of the lead acid batteries. So it cannot perform at all temperature ranges that we require, and it has very low calendar and shelf life. So all of these disadvantages have made sure that we don't have such sizable applications of lead acid technologies in today's world. Next up is nickel metal hydride technology. These have, we could call it as a mid-range in terms of energy density and the performance of the batteries. And they are used mostly in computers and medical equipment. So these are the applications of a nickel metal hydride battery. Even though they have pretty good energy density and high energy power and efficiency, they are not used in electric vehicles because it's very costly, and disposal of nickel metal hydride batteries is also very difficult. So these are the disadvantages which have made sure that we cannot use these batteries for electric vehicle purposes. Even though researchers are trying to use these for hybrid electric vehicles, we'll have to wait and watch what's the future for nickel metal hydride technology. And last up is the most popular lithium ion technology. You name an application and it is present every single place. I mean, you talk about the cell phone, your small RC vehicle, a remote control vehicle, or to the electric vehicle that you see on the road, most of them have lithium ion technology as their battery. Why is that so? It has very high energy density, high energy efficiency. It can perform at almost every temperature range that is available. And most of the lithium ion technology components that make it up are very easy to recycle. Even though the cost is pretty high, scientists are looking at more feasible ways of using the lithium ion technology. So at least for the next 10 years, we don't see any other alternative to lithium ion technology. What if your battery pack is having sudden temperature fluctuations, or that it's not charging or discharging at the prescribed rates? We then turn to the battery management system. So what is a BMS?
Battery management systems are basically monitoring systems to evaluate how efficiently a battery is working and to pick up any irregularities in its operation. This is vital for lithium-ion battery technologies as the batteries are quite sensitive to being overcharged. While traditional batteries take on a full charge and then stop charging, lithium-ion battery technology continues to absorb the current. This has the same effect metamorphically as overfilling a water balloon. The result is an explosive release of extra content. Therefore, lithium-ion batteries have overcharge protection, which means it can either warn the user or cut off the supply as a whole to prevent an explosive release of the battery. Think of it being like a circuit breaker or a fuse cutting out to prevent the collapse of a system as a whole. Battery management systems can monitor almost everything that a battery does. Apart from being responsible for balance charging the cell, they also offer various other protection features like short circuit protection and over temperature protection. Hence, BMS plays a really important role in the overall security and safety of the car.
Moving on, we come to the last subsystem in our electrical overview, that is the motor controller. So what is the primary role of a motor controller?
Motor controller. This is where the magic happens. This is the brain of the entire system. The energy from the battery has a small pit stop to make before it reaches the motor, and that is the motor controller. Remember the 1 2 3 2 3 1 sequence I talked about? Well, motor controller is the dude who senses the 120-degree movement and initiates the next sequence. It decides which sequence comes next and initiates that. This is exactly why we need, or why a BLDC motor needs, a motor controller. Because unlike brushed motors, controlling the speed isn't as easy as just varying the supply voltage. The input from the throttle decides the magnitude of the current supplied to the phase wires, which increases or decreases the speed. A motor controller can essentially have two stages, the controller stage and the power MOSFET stage. The controller stage has a microprocessor in it, and which is where all the computation happens. All the inputs from the throttle, hall sensor, brake levers are taken and the output is decided. The power MOSFET stage, well, has MOSFETs in it, and these MOSFETs are arranged in an H-bridge configuration to power the phases. Since MOSFETs are not operated at logic levels, that is at 5 volts or the level at which most microcontrollers will operate at, they can't be directly paired with the MOSFET and hence require another component called MOSFET driver. Now, DRV8302 from Texas Instruments is a popular choice and is a very great example for a gate driver. Now, all this paired with some very efficient code makes a very responsive motor controller.
With this, we come to an end to the electrical overview segment in the Supermileage show. We hope we have given you a fair idea of what are the electrical subsystems that actually make the electrical components of our vehicle. In the next episode, we'll be talking about design in particular and what goes into the design of an electric vehicle, to be precise. Hope to see you soon.